In this video, let us see how we can do basic exploitations like measure and match the images which are not spatially matching. Once these are done, we will see how to create map reports and also send the contents of the 2D view to a PowerPoint presentation, to a Microsoft Word and to a GeoPDF. Let us display an image and rotate it to an angle how it was when the sensor captured it. Let us zoom into an area where we have light poles. To have a closer look of a particular pole, we can make use of an inset view. Changing the size of the source will accordingly change the extent of the inset view. The Inset tab would show up when the inset view is selected in the Contents panel. The symbology of different parts of the inset view can be changed individually, or we can have the same symbology for all of them. The image in the inset view can be zoomed in or out, or pan can be performed using the mouse scroll wheel. Let us start measuring the height of the light poles using the Measure option in the Home tab. Select the Height from Layover option from the Measure group. Click on base of the pole and then the top of the pole. Notice that the measurement is shown in the Measurements panel, where we have an option to enter any comments too. Similarly, we can measure the height of the pole by measuring the respective shadow. The same option can be used multiple times by locking it. Alternatively, we can also automatically display the height of a measurement as an annotation in the viewer itself. Select the Annotate option, which would create an annotation layer in the viewer. Now let us measure the height of the pole by using another option, Top Shadow Height, and lock the same option so that we can use it multiple times. Click on the top of the pole and the top of the shadow. Notice that the height is shown as an annotation. Using the Polyline option in the Measurement group, we can measure the length of the runway, which would also show the annotation. We can modify the text that is displayed by resizing, relocating, and by selecting multiple styles available in the Styles library. For the sake of creating a report, we can create a bracket for these poles and place a text showing the average height. We can delete the individual annotations and create a single text displaying the average height of all the poles. Again, we can resize, move the text as we want. We can switch on the Inset view and switch off the Measurements panel. We can send the contents in the viewer to a PowerPoint by a single click. If PowerPoint is already running, then this option would add a slide into it. If the PowerPoint is not open, then this option would launch PowerPoint for us and create a slide with the contents in the view. This is how the PowerPoint looks like, which would contain all the annotations, area of the image, and inset view that are available in the Imagine 2D viewer. Coming back to Imagine, we can also send these contents to Word by a single click. The behavior is similar to the PowerPoint as we have seen a while back. We can create a map report of all the contents available in the viewer. For this, we will have to make sure that we select the 2D view in the Tree view of the Contents panel. We can select a template from the already available templates. This would start Map Viewer with all the contents in the 2D viewer fit into the template we selected. This would start Map Viewer with all the contents in the 2D viewer fit into the selected template. We can either change the unresolved variables manually within the Dynamic Text Editor box, or we can do it manually in the Map Viewer. In order to change the title of this map report, let us double-click on the title and enter the appropriate text for the title of the report. Similarly, we can change the subtitle of the report too. This report can be printed as it is, or again can be sent into PowerPoint or Word in a similar fashion as we have seen a while back. Now let us see how we can match two images which are not spatially matching. Let us display the two images from the shoebox in two different viewers. Let us zoom into an airport area within the first image and then spatially link and sync it with the second viewer. The same portion should be displayed in the second viewer too, and the scale can be equalized in both the viewers. Let us zoom to a particular area and launch the Inquire cursor. We can notice that the Inquire cursor in the two images don't show the same area. This can be corrected by using an option called single point and digitizing a point of same area in both the images. This should align the images to each other and should be spatially matching. This can be verified by again launching the Inquire cursor. Now that we have spatially matched the images, let us create a map report by highlighting the hangar facilities and counting the decommissioned and active cargoes in the image. The type of layer that needs to be created while digitizing a polygon is controlled by this preference. Let us select the polygon option and start digitizing polygons in the viewer. Polygon styles can be changed by using the already available options in the Styles gallery. Other symbology changes like line color and style can also be applied. The same symbology will be carried over to the new polygons that are digitized subsequently. We can create a text and change the style, font size of it by selecting the appropriate options. We can also resize and move the text as we have seen earlier. Polylines with a specific style can also be drawn. Now let us see how we can place geopoints. Select the geopoint option for the geopoint tab to show up. Select the place geopoint option and click in the viewer to show the coordinates of that point in the same coordinate system of the image displayed. We can again change the style of the coordinates. We can also place a geopoint in a different coordinate system other than the image. Here we can see the geopoint being placed in MGRS. Let us now see how to count the aircrafts and discriminate the counts into two categories, A and B. $N is a notation used to start the counting and placing of the geopoints. Place A before $N and start placing the geopoints on the aircrafts. Notice that geopoints incrementally increase their count by 1. Once the geopoints for A category are placed, let us reset the number back to 1 and start placing the geopoints for B category. Let us create a legend for the A and B categories. This can be done from the Drawing tab by selecting the text option and typing in the appropriate text. Let us send this report to a GeoPDF. This option would send all the contents in the viewer into a GeoPDF, which can be viewed in an Adobe Reader. To check if the coordinates are showing up in the Adobe Reader, let us select the measure option in it and switch on the geospatial location tool. Hovering the mouse over the image would show the coordinates. Let us now create a map report by selecting a template such that both the 2D views that are displayed would be part of the map composition. From the map composition, which is carrying the map report, we can make changes like moving the annotation, applying the brightness or contrast for images individually displayed in both the viewers, changing the font size of the annotation text and resizing the text box. This map report can again be sent to a PowerPoint or Word or even to a JPEG file.